Good afternoon and welcome to today's instalment of the Strategic Farm Results Week 2021. My name's Richard Meredith. I head up the Arable Knowledge Exchange team at AHDB, and it's my great honour to be chairing this webinar for you today. As I'm sure you're all aware, it's one of 5 webinars that we're running this week, delivering all the strategic farm results. Before we go into the content for today, I'm just going to run through the housekeeping slides for you. If it's all right to go to the next slide, Michelle. So you're all on mute. We can't see or hear you. You'll be glad to know. Don't worry too much about that. There is a questions box on the side of the bar. Please feel free to input any questions into the webinar as we go through. We will be having a planned Q&A session at the end where we'll bring together all the speakers and ask a lot of questions, but we can kind of put in some as we go through. On that similar vein to that, we have the speakers, and then we'll be coming on to the Q&A panel session at the end. It's 12:32 now. We have up until 2 o'clock. We'll keep on going as long as we have questions coming in, so please do make sure you feed them in. Basis and the ROSO points are on offer for attending this webinar today. If you enter your basis on the ROSO details into the box, to the question box, then that should be able to be sorted for you. So that'll be your name, the basis on the ROSO number, your date of birth, and the postcode. This is being recorded, just to save you if you're frantically making notes and trying to capture everything. It is recorded and put onto the AHDB YouTube site afterwards. So don't worry too much if you miss anything. And as always, please do feel free to mention it on social media and any other platforms as we go through. So yeah, next slide please, Michelle. So today's meeting, I'll put it in kind of a simple form here. After I've got through the introduction here, we're going to go over and do the strategic farm results for the West with Anne Bhogal from ADAS. Then we'll be switching to the East, where we'll be talking to Nathan Morris from NIAB, and then we'll be going to the South strategic farm with Callan Scottson from NIAB. We'll then be going to an open panel discussion session which will be fueled by your questions. We're joined by David Miller, who's the Strategic Farm South host. We'll put our hands up. We were supposed to have Brian Barker with us this week, but he's had the joyous news of a new arrival in his family, so we've let him off this week. We'll be having him join us on the video halfway through though. But we'll be coming together at the end to ask all the questions about the content that we speak today, and really kind of chatting to David about how he feels the information could be used in a practical scenario. So next slide please, Michelle. Just the usual plugs here is before we get into the content. There's 21 monitor farms and 3 strategic farms in the UK at the moment. Make the most of it. They're really our platform for getting AHDB information out to you. Looking at that map, there generally is usually a farm nearish to you. We're always going to be evolving that program. We're currently about to start recruiting for the next phase of monitor farmers to fill in any gaps on that map. But do get involved. But we've obviously got the strategic farms in the south, east, the west, and in Scotland. So yeah, get involved. Thank you, Michelle. A main conduit for doing that, getting involved, is our KE team at AHDB. We each have a patch that we cover of the UK, and we're your kind of eyes and ears on the ground. All our contact details are on there. Please feel free to contact any of us with any kind of questions, queries, or steerage of what you'd like us to see us doing, and any thoughts and challenges. You'll notice that there's a couple of duplications on there. We are currently recruiting for East Anglia and the Scottish roles, so watch this space for people coming into those roles. Thanks, Michelle. Finally, on the people front, we've also got my colleagues Emily Pope and Fiona Geary. They really are the driving force of the strategic farms. In particular, it's their project that they run. The great content that we have to speak about today is created and implemented by them on the farm, and they really they work with the host farmers and the researchers that we're talking to today, and act as that crucial link between the two. And yeah, just to acknowledge how grateful we are for all their hard work. Thanks, Michelle. If you do want to go find out where all your local events are, please do go onto the AHDB website and click on the events thing. You put in your postcode and it tells you where you can go in the coming weeks, and there's plenty going on. Thanks, Michelle. In particular, we have got the Agronomist Conference on the 7th of December. So if you look on the events portal, you'll see that there. That's a hybrid this year, so it's a new word that's come on the back of COVID. Is hybrid event is having a joint online, digital, and in-person event. We've got limited spaces left in person, but there are spaces, and you can also join online. This is really kind of one of the kind of pivotal conferences for us at AHDB, where we communicate all the levy-funded work which we do in a one-day format. We also disseminate that information out in the regional agronomist conferences that we have around. These are a bit more kind of regionally tailored towards your area and your requirements. There's the list of them there. But yeah, get involved. They are there for you. Thank you, Michelle. So coming up this week, you're obviously here today on the Wednesday. We're looking at catch crops and cover crops and really asking, can they help provide a more profitable and productive arable enterprise? And the results we've got today, we'll be looking at the kind of key messages coming out from those. But we've also got two more events at the same time, 12:30 on Thursday and Friday. So tomorrow's one on Thursday is looking at the soil management practices and how they can build resilient production systems and improve your soil health. So we'll be looking at the various trials, looking at soil management there and cultivations and crop establishment. And then finally on Friday, we're closing off the week with asking the question, what makes land marginal, and what do you do with it both for profitable and create a more profitable and better environmental angle, and looking at kind of using your land to its best advantage and at a profitable level. And then finally, we'll be concluding the week with a podcast recording. All the farmers, strategic farmers, and our new strategic farmer in the north, David Blacker, are coming together to record a podcast, really kind of having a bit of a chin wag about everything that they've learned this week and what they're going to do going forward with the information, because there's some really powerful stuff coming out, and it's really important for us to look at how it's used by the practitioners going forward on their farms. Thanks, Michelle. Final one for me is that I mentioned earlier that if you want to watch any of these back, we have a huge library on YouTube. So type into Google AHDB Cereals and Oilseeds YouTube, and you'll come straight to our library. It's got everything that we've done online in terms of webinars and seminars and workshops, and everything is recorded and put up there. That's there, and it's a kind of really kind of a huge resource to go to. And I don't think there's a really kind of many farming topics that haven't been covered over the last 18 months or so, as we've been doing so much online. So really do use that. There's a lot of stuff we don't want to just kind of regurgitate it all the time, but go back in there. So right, going on to today's main topic, where we're looking at cover crops and catch crops. We thought we'd just we'd open with a poll question, and hopefully Michelle's going to be able to load that onto your screen. And really, this was just to kind of gauge the temperature. And I think we know which way it's going to go, but we're going to gauge the temperature. If you could just kind of complete the question in front of you. Do you include cover crops in your rotation? So you've either got yes, no, or not applicable if you're not farming yourself. So if I could just I'll give you kind of 5, 4, 3, 2, 1. I think we'll look at the results. Brilliant. So we've got quite a split audience. So we've got 30% are advisors or not applicable. 28% are not using cover crops. So hopefully the information today explains to you, if you were going to do it, then what benefit they would bring to you. And then you've got 40% saying yes, you do use cover crops in your rotation. So hopefully today's information will either reinforce or kind of help tailor how you do approach it going forward. So thank you very much for getting involved in that. Just lets us kind of see what the audience are up to. So Anne, I'm gonna pass over to you now. You're our lead researcher on the Strategic Farm West project. The backstory there is that it's last year was this year, so this is the final harvest that the Strategic Farm West has gone through. The farm manager at the farm, Rob Fox, moved. He was a farm manager there, so he moved roles and he's gone to a different role. So that project came to a natural end because we needed the strategic farm host. There's no other way of putting it. But Anne's been a fantastic kind of lead for this project, and I'm going to hand over to her now to talk us through the catch crop and cover crop, catch crop trial that we did there. Thanks very much, Anne. Cheers.
Thanks, Richard, and good afternoon, everyone. It's really good to be joining you this afternoon. So I'm a soil scientist in ADAS, and I've been working with AHDB at the Strategic Farm West for the last 3 years. So I'm just going to share some results from a catch crop trial we've had. So first of all, I want to, if you dare, cast your mind back to autumn 2019. Not a pleasant autumn for anybody trying to sow any crops. This is just the average Met data that shows for the country the autumn rainfall and the winter rainfall as a percentage of the average. And you can see that in the autumn, that's September, October, November, large swathes of the country. So blue means over 170% of the average rainfall. And then even in extending through, basically the rain didn't stop. So if we click to the next slide, please, you can just see what it was like for Rob over in Leamington Spa. This is the last 3 years worth of Met data for his farm. The bars are the rainfall, the monthly rainfall, and the lines are the average temperature. And if you just look at the green bars, which was for the harvest 2020 year, so autumn 2019 through to July 2020, you can see those big green bars in September, October, November compared to the previous year, the blue bars. Then just thinking you're going to get a bit of respite in January and February, a massive amount of rainfall, not helped by 5 storms as well, named storms that the country received. So this, on top of some quite heavy textured soils, meant that Rob actually really struggled to get crops in the ground. He did a better job as he could, but he did have land where actually he couldn't get anything in. And so the decision that gave us the opportunity to sort of think about, well, what do we do with that piece of land? Do we just leave it fallow for the year, or can we do something that might improve the situation? So if we just click to the next slide, please, Michelle. We set up this trial to assess the impact of what we called a summer catch crop. So putting a crop in rather than leaving it fallow. And we wanted to see, does that have any benefit in terms of capturing nitrogen, improving the soil structure, and the performance of the following crop in the rotation, which was last season's crop. So if we click through and just have a look at the structure of the trial, it was rather a tricky field, so it 60% clay content, so it's no wonder Rob struggled to get on with all that rain and a clay soil. So basically we had, he had lightly cultivated eventually, I think in early May, the field. So we had a sort of lightly cultivated stubble control. And then we put in 2 tram lines worth of a farm standard catch crop. So whatever Rob had left in his barn, some barley and beans, and then a commercial mix supplied by RAGT seeds, which we selected to potentially improve soil structure, but also capture any nutrients that might be swimming around. But one that was fairly simple and relatively cheap. So if we click to the next slide, please. These were drilled in May. In fact, we went from wet, wet, wet to bone dry. So we were wondering whether they'd actually get going, but they did. Here's the beans and barley, late June. So really good dense cover, beans in flower. If we click through and have a look at what the phacelia and radish were doing. Again, some good establishment there, a nice cover. And then finally, if we just have a look at the weedy stubble. So actually we had quite a decent cover of weeds, but quite patchy and more variable. If we look at the performance of those catch crops come sort of end of July, when we were going to destroy them, you can see on that weedy stubble about 70% cover compared to that really lush, dense beans barley catch crop at 93% cover. In terms of the dry matter production, we actually got about 2 tons of dry matter from the control, and almost 3 from that beans and barley, and 2.5 from the Phacelia radish. In terms of mopping up any nitrogen that would have been mineralised over the season, about 50 kilos in the weeds, and almost 100 kilos where we got the beans and barley, and then 80 on the Phacelia radish. So looks like we might have got some additional nitrogen fixation from the beans being in that mix. So we wanted to see how that nitrogen might become available for the following crop. So this is the autumn soil N supply. So by soil N supply, I mean soil mineral nitrogen down to 90 centimetres depth. That's ammonium and nitrate. That's the blue part of the bars. And then what we managed to get in the catch crop. You can see that there wasn't a huge difference in the soil mineral nitrogen, maybe slightly less on the Phacelia radish. The bulk of the differences in that soil nitrogen supply being due to the amount of nitrogen captured by that catch crop, with the beans and barley coming out on top, almost 130 kilos potentially there available going into the autumn. So Rob then went to put in winter wheat. So if we click through, when he went to cultivate, these were his pictures, and this he commented that actually where the cover crop had been, the catch crop had been, the soils were a lot drier and much easier to work, less horsepower required. Whereas his description of he's called it natural regen, that's so that weedy stubble, he described it as a lot sadder ground requiring extra horsepower. In terms of the winter wheat establishment, we looked at that by measuring NDVI, so just looking at cover really. And we're actually, this chart shows from October through to the end of November. And we actually saw very little difference in terms of the establishment of the winter wheat. It did rain again, unfortunately, in September. And Rob's comment was that actually the ground had slumped back down again, and he wondered whether that had sort of negated any sort of benefits that the catch crop might have had. Some divergence appearing towards the end of that monitoring period. But we actually wanted to see, okay, were there any differences in soil condition as a result of having that catch crop in place? So we used visual evaluation of soil structure to do this. This is where you take a spit of soil and you score it according to the size, the shape of the aggregates and how easy they are to break up. So a score of 1 or 2 will indicate a nice friable soil with rounded aggregates and roots and pores throughout, whereas a score of 4 or 5 indicates that actually we've got some compaction present, the aggregates are quite angular, roots are limited to the cracks, and there's a really much lower porosity. And we score the whole block, but we also look for what we call the limiting layer score. So what is the highest score and where is it in that depth of that spit of soil that we've taken out? So these are the scores that we measured. Sorry, can you go back, Michelle? These are the scores that we measured on the different treatments in the autumn, and then we repeated it in the spring. We actually saw no statistically significant difference, but you can actually see that the scores are lower, particularly in the autumn, where we had the catch crops present, so a slightly improved soil structure as a result of those treatments. Not evident though in the following spring. It was a lot drier, and soil dryness does have an impact on how you score the soil. It's harder to score a soil if it's particularly dry. So now if we click on, while you're doing the assessment of soil structure, you can count the number of worms that you see in that spit of soil. So this is a worm count, numbers per pit at those two different sample timings. And again, we saw no statistically significant difference, but actually numerically, certainly in the autumn, we saw a higher number of worms where we had that catch crop present. Less evident in the spring when we had those drier conditions. And we're looking to anything over 8 worms in a pit is considered to be a nice active population. Anything less than 4 is a potentially depleted population. So if we just click on now, so I want to look at what was happening to the nitrogen that we captured in that catch crop. So this table basically shows what we measured in that autumn. So that chart that I've showed just previously, the soil mineral N, the catch crop N, and therefore the soil N supply. And then we did the same measurements in February when the winter wheat was present. So we measured soil mineral nitrogen to 90 centimetres, and we looked what the winter wheat had captured. Interestingly, there was more nitrogen in the winter wheat on the control plots compared to the catch crops. But even more interesting was this the soil N supply. You can see, if you look at that final column, the control, 44 kilos of soil N supply in February, almost matches the soil mineral N that was present in the soil in August. Similarly with the beans and barley, quite close agreement. And finally, the Phacelia and radish, again, quite close agreement between the February soil N supply and the August soil mineral N. So it looks like we've not accounted or not been able to find, as it were, that catch crop N, that up to 90 kilos from the beans and barley. So 2 reasons for this, potentially. One of them could be that that nitrogen has been released and has been washed out of the soil, been leached, or in the drains. Alternatively, it could still be locked up in that organic pool, in the microbial biomass and in the organic undecomposed materials. And it's a guess in some respects, but I would hedge my bets towards the latter, given that we're looking at a clay soil which doesn't drain particularly well. So it would be interesting to see actually when that nitrogen actually does become available. Would it become available in this next season, for example? So if we click onto the next slide, this is the yield map that we eventually saw, so the winter wheat grain yields. And you can see the different tram lines and you can see the colours of the map. So basically red indicates low yield and blue indicates a high yield. You can see there's quite significant spatial variation, and that is linked to some underlying variation in soil texture, with that top corner, top left-hand corner, being slightly heavier textured than the bottom right-hand corner. Now, the analysis that we do, the ADAS agronomics analysis, will account for that variation as best as possible, and we allocated the treatments to try and account for that variation. So we saw actually that there was no significant difference as a result of having that previous catch crop. 11 tonnes on the control, the beans and barley slightly up, about 0.3 tonnes higher, the oil radish and Phacelia slightly down. But as I say, these were the variation, and these were not significantly different. So finally, if we go to the next slide, please. So really my sort of key messages are sowing a catch crop either between cropping or where you've not been able to get a crop in the ground because the weather has been so bad in the autumn and early spring, does provide good cover and does capture nitrogen. And I would say that having a catch crop, drilling a catch crop, will provide more consistent cover than leaving it fallow. And there is the potential, there are little hints that it has, they can potentially improve soil conditions for autumn crop establishment. Rob would certainly agree in terms of just the fuel that he used to cultivate the land would support that. Inclusion of a legume in the mix can capture that additional nitrogen, but as I say, I think predicting when this nitrogen will be released remains a challenge. And I would say that improved cash crop yields are not guaranteed following a single year of catch or cover crops. And often benefits are only seen when they've been incorporated repeatedly into the rotation over the long term. And that's where I'd like to end it. Thank you for listening. Thanks,
Brilliant.
Richard.
Thank you, Anne, and a pleasure to listen to you as always. I'm going to segue us straight into the next section. As I mentioned, keep questions coming in, and we'll revisit them as we get to the end into the panel session. So please do send them in. I'm going to segue straight into. I mentioned that we're going to have a short video from Brian Barker, who is our Strategic Farm East host. Obviously, Brian's not with us today, but he did have the time before he had a child to record us a short video, really kind of outlining the trial and the key messages that are coming out of his cover crop trial at his farm. So the power of technology. I'm hoping that Brian will appear in a moment.
So the final trial that we've been sort of looking at this year is the catch crops and cover crops. Over the last few years, we've introduced more and more this idea of a broad spectrum diverse mix being planted straight behind the combine to act as a nutrient sponge to absorb the nitrates and any other available nutrients that haven't been absorbed by the commercial crop that's just been harvested. This acts as a sponge. We've seen from the water analysis that we've done over the last 5 winters that where we've got these diverse mixes growing over winter compared to an overwinter traditional plough, that we are absorbing huge amounts of nitrate. And when we're looking at where the industry is being taken by government policy, where the idea of public money for public good, the polluter pays principle, this may be something that we've really got to understand. And so the more information we can learn and get about this system of introducing these catch crops and cover crops, and then making sure that the commercial crop following them is actually delivering profit, means that our whole farming system is being beneficial from, means that our farming system is benefiting from having these mixes integrated into them. It also means that we can bring livestock back onto the farm. So we've had sheep come back on the farm, which again gives us another element to our business and another enterprise that we can draw in and bring income onto a farm, which traditionally we haven't had for the past few years. But now we're looking at the legacy effect of these catch crops and cover crops, and when does the absorbed nutrients, does it just get absorbed by the plant and then not released? And so now we're looking at the legacy, not year 1, year 2 and year 3, of when or if that nitrate that's been absorbed and that other nutrition that's been absorbed, will it actually come back to be available for future crops, especially when we're looking at how we're going to go forward with high nitrogen prices. Can we make sure that we can cycle what's not been used much better for commercial crops? And so we've got to be much smarter and look at our farming system to make sure that we're not wasting. Over applying is the first thing that we've got to look at to make sure that we're not over applying in the first place, but anything that's not picked up by the commercial crop, can we keep it on farm and make sure it doesn't just go down the farm drain into the watercourse and into the North Sea. So we've got to be very careful and again look at these things. And again, I would be a great advocate for saying everyone's got to try it, look at it, see if it works in your farming system. You don't need a fancy drill to do it. You can try it, spray it off early, and make sure that your following crop goes in good conditions in the spring. The mixers that we've used have changed over time. When we first bought and tried them, we were buying off the shelf mixes. Then we've been taking advice from many great people around the country, discussing yearly, because everything changes and there's a lot of research being done, so there's always something to try. But again, speak to the seed distributors who are doing a lot of research into this. We've gone away from brassicas because we've reintroduced oilseed rape onto the farm. We're using lots of vetches, clovers, linseed, cereal-based. Phacelia is a great one on our clay soil, but you just got to learn and practice and experiment, because certain species will be better for your soil type and your farming system. So again, very much trial and error.
Brilliant. It's great. It's almost like having Brian here, wasn't it? So thank you very much to Brian and for taking the time to do that. Brian mentioned there in his video that kind of the industry is really how it's looking at these things at the moment in terms of the fertilizer price, and kind of from that angle. I was over in the DIS monitor farm yesterday, and we're really kind of looking at the break-even point and the economic optimums of when you apply apply fertilizer when you bought it at these kind of higher prices. And so AHDB are going to be doing a lot of work over kind of the coming weeks, disseminating all that information, helping you understand that. But this kind of cover crops really fits in nicely with that, because it can provide such benefits in terms of an alternative, which takes me on to introduce our next speaker for today, who's going to be delivering the results for the Strategic Farm East cover crops trial, and that's Nathan Morris from NIAB. Nathan, thank you very much for joining us today, and without further ado, I'll hand over to you to lead us through the trial at Brian's.
Okay, thank you very much, Richard, and good afternoon, everybody. I'm Nathan Morris from NIAB, and I'm the Soils and Farming Systems Specialist, and have been working with Brian in the past year on the SF East farm to look at the cover crops and what they can do in terms of both their function and also their sort of legacy effects across a rotation. Next slide, please. So first of all, I was just going to give a brief overview of the trial at the SF East farm. And the objective really was to continue to monitor the performance and the legacy effects of the cover crops in the following crops in the rotation. In 2020, there was a spring barley, which was obviously previous to that had the cover crops in, and now these fields are now down to a 2-year herbage grass. The two fields are split between basically a system where we had a plough with the cover crop, and then an overwinter plough, a more traditional approach. And then the other field, we basically looked at a single pass with the cover crop straight into stubble, and then the other area was just a stubble. So we've been, as I say, continuing to monitor these areas to look at the basically the supply of soil mineral nitrogen, both for the soil and also what nitrogen gets captured into the crop. We've also been working with Essex and Suffolk Water, looking at drainage water and to look at the effect of nitrates going into the drains over that winter period. And we've also continued to look at some of the soil physical structure, things like the soil penetrometer, bulk density, and the visual evaluation of soil structure, as Anne mentioned just previously, and again, earthworms. So next slide, please. So we have a few results from the season that I'll just talk you through. The first one being where we started. So in the autumn, we looked at the soil nitrogen supply. We took the nitrogen cores down to 90 centimetres using a mechanical corer. And the results basically showed that the herbage grass had started to capture anything between about 15 to 45 kilos of nitrogen. And the SMN again varied quite substantially between about 33 and 76 kilos of nitrogen. And interestingly, when we look at the graph on the screen, we can see that actually most of the treatments had around about 30 to 40 kilograms SMN in the system, but it was the single pass system with the cover crop where that soil mineral nitrogen supply had doubled really. And as you can see from that, we had much more soil mineral nitrogen, but less had actually been taken up into the crop in the crop biomass. The crop biomass in that particular treatment, that one pass system, was only about half a tonne compared to the other systems where we're anything between 1.1 and 1.7 tonnes of biomass. So from that, we could see that there was, as I say, less nitrogen in the crop, and that nitrogen that was in the soil, obviously at that time of year, and as we all know, that autumn was particularly wet, was at higher risk of losses into the water. Next slide, please. So, as I mentioned, we'd been looking at the soil water or drainage water for both nitrates, but other nutrients as well that obviously can be lost into the water. And obviously this can be a concern both for the water companies for processing, but also obviously the wider impact on those rivers and water courses for their environmental quality. So when we're looking at these drainage samples, we started off in October when the drains started running, but at that first timing, one of the drains in the treatment hadn't started running yet, so hence the result came back as 0. But all the other drains had started running, and you can see from the very outset there that the one pass system had much higher nitrate levels. In fact, there were about 3 times the maximum level that's the drinking water level of 50 milligrams per litre. So we can see there that actually played out through the whole of the winter period, that most of the other systems had nitrate levels at or below the drinking water limit, but that one system did keep increasing the nitrate into the drains, which obviously is a concern. So I've tried to look at perhaps some of the reasons why that might be, which I'll come to in a minute. Next slide, please. So as we progressed into spring, and obviously the weather basically switched from being that particularly wet autumn and winter to a pretty dry spring, the drains stopped flowing, and then we continued to look at the nitrogen captured in the crop and in the soil. So our spring soil mineral nitrogen and crop assessments showed a much more even level of nitrogen both in the soil and also in the crop. So most of the crop biomass was around 1.3 to 1.5 tonnes per hectare, and the nitrogen was around 50 kilos SMN. So a lot more had been taken up by the crop, but also there had been those overwintered losses. Okay, next slide, please. And then we continued through the season. So these samples were, again, we took measurements in June, looking at the soil mineral nitrogen supply. And at that stage, the SMN supply was really quite low. That was down to between 14 to 25 kilos of N. So most of the nitrogen that had been in the soil had been taken up by that grass, and also there had been applied nitrogen as well, which was obviously also substantially taken up by that crop. So we can see here the biomass of the crop were anything between about just under 11 tonnes a hectare to about 15 tonnes a hectare. And again, you can see not much difference between the different systems, but the plough-based system had the highest nitrogen supply at this time. Okay, next slide, please. So one of the indicators we can look at is sort of, to help with soil function is earthworms. We did these in about spring 21, I think it was about April time we looked at them. And as I mentioned, the very dry weather obviously does have an effect. So the numbers here are particularly low. and what we did actually see was an absence of adult anisic and epigeic worms in the system. There was a lot of juvenile, or some juveniles, but not substantially differences between the treatments, but numbers were much lower than we would normally expect. And as I say, I think that was mainly driven by the dry spring weather. But obviously, when you do have low earthworm numbers, that can lead to a lower, if you like, of earthworm mediated soil functions that they carry out in the soil. So we will be continuing to monitor these to see if we get a change or shift in the populations in the coming season. Next slide, please. So one thing we can do is look at the range of parameters that we assess and put them into a slightly more digestible format that hopefully just helps to indicate which particular measures or attributes are of concern, or in which ones we don't have to worry about so much. So this is basically the scores have been color coded according to the soil health scorecard, which has been developed as part of the AHDB and BBRO Soil Biology and Health Partnership. And as we can see from the number of attributes there, things like soil organic matter are very good across the board. pH, there was no concerns there. Extractable P in most instances was good, just a little low in the cover crop plough treatment. But again, we can continue to measure that and monitor. The other measurements in terms of the potash and the magnesium and bulk density levels were all in the desired indices. The VEST score was slightly higher in some of those treatments, coming out as a 3, and limited slightly by a slightly hard pan a bit below the surface. But again, that's something just to be monitoring. And the penetrometer resistance here, although the scorecard puts scores sort of below 1.3 as being good, and then anything between 1.3 and 2 is something to monitor. You can see there that the cover crop 1-par system that we saw earlier, having lower nitrogen supply sort of getting into the crop in that winter period, and the higher nitrate losses, also had an increased soil strength that sits just below the sort of 2 megapascals, which is basically at a level where you would then be more concerned and would need to be investigated. But it is higher than the other systems, and I do wonder slightly whether this had an impact on then that nitrate movement into the water courses. And then, as I mentioned, earthworm numbers were much lower than we would have expected, but I think that was very much a driver of the season in the spring, low spring rainfall. Okay, next slide, please. So if we just think a bit about why we might be seeing that effect of the nitrate losses, these were the yield maps from the spring barley crop in 2020 for the 2 fields, and you can quite clearly see there the split between, if we take the top map, the left and the right hand side. The left hand side was the plough, and the right hand side was the plough. Left hand side was the plough with cover crop, and the right hand side was the plough based system. And the bottom map there, the top basically had was the stubble. The bottom was the stubble with the cover crop. So, as had been reported in earlier findings, there was a lower yield from that barley in the cover cropped areas, and was likely as a result of a combination of slug damage and poor establishment due to the wet soil conditions. The yield reduction, I suspect, may have increased the high residual nitrogen supply left after harvest. And as I mentioned, when we were looking in the grass crop, when we saw the nitrogen supply getting into the grass, that was lower in that particular system. And that combined, I think, with the higher soil strength that we saw, may have led to slightly reduced root growth in that treatment, limiting the nitrogen uptake and therefore allowing that nitrogen to be more easily leached into the drains. So that's one of the concern where we have potentially lower than expected crop yields and residual nitrogen that obviously, if not captured in the following crop, is much more likely or liable to be leached into watercourses. Final slide, please. So my main take-home messages really are that we do need to make sure that we have good performing crops across the rotation, and that they are not limited by any topsoil structural limitations that obviously could lead to nitrate leaching. And obviously, when we are looking at cover crops in the rotation, we do sort of need to look at those performances, just not in the single year when we're using them or growing them, but also in the following crops, and then link those to the cultivations and the topsoil structure, and also think about the crop performance as well of those cash crops, as to whether there may be nutrients that are in the system that we need to minimise being lost to water from leaching. And that's my key messages really. Thank you very much.
Brilliant. Thank you very much, Nathan. Before we go over to Callum, one very quick question that has come in is, I didn't mention the establishment date of the cover crops. Do you know when Brian established them?
So the cover crop was in the previous spring barley crop. So those were sown prior to the spring barley. So that would be autumn 2019 that the cover crop went in, destroyed in spring 2020. And then the spring barley was undersown with the herbage grass. And then that's where we are. We are now looking at that sort of legacy effect of the cover crop in the rotation, which is the interesting part.
Brilliant. Thank you very much, Nathan. That's fantastic. And I'll be drawing you back in after Callum with some questions. Thank you for running us through that and for all your hard work into producing the information. We're going to do a second quick poll of the webinar. So by the power of magic, it should come up now. So if you plan to use cover crops, what is your main reason? Please select one. So either reduce your nutrient losses, control soil erosion, improve soil structure, build soil fertility, or manage weeds and soil-borne pests. So I know the holistic approach, you're bringing all of those in, but if you have a predominant reason, what would you say it's for using cover crops? So we'll do kind of 5, 4, 3, 2, 1, and we'll go to the results. So improving soil structure takes the extended lead there of 60%, and then you've got followed up by building soil fertility and reducing nutrient losses. And brilliant, thank you very much for participating in that. Just another, again, helps us identify what's going on in the audience. I'm going to come to our final researcher of the day. Callum Scottson has been working with David Miller down at the South Strategic Farm in Hampshire, and he's going to run us through some of the results that they've got so far, because this is the first year of the Strategic Farm South. So these are kind of the preliminary findings that they're finding coming out of there. Thanks, Callum, and I'll hand over to you.
Yeah, hi everyone, thanks for coming. So I'm Callum. My background is in sort of where plant science meets soil science. So it's looking at how plant roots interact with soil, how they structure soil, how they interact with soil hydrology, and all of that sort of thing. So I'm going to be talking about essentially outlining the Strategic Cereal Farm South. So it's in its fairly early days. It's been running for about 2 months now. So we've got some very early sort of baseline data. Mostly it's about discussing what the work's going to involve and where the next few months are going to take us. So next slide, please. So there's 4 work packages involved within this wider project. So 2 of them I'm going to be focusing on today because they largely cover cover crops. So work package 1 is looking at cover crops and water quality. So we're looking at different cover crop mixes. I'll cover that in a bit more detail in a second. The second one is looking at different management strategies and how that influences soil health, and actually importantly how that influences the nutritional value of the crop that you get out at the end. Work package 3 is then looking at establishment and early crop growth, and we're using 2 essentially soil inoculants and looking at how those aid establishment and early growth. And then finally, work package 4 is looking at farm scale monitoring. So that's all in terms of looking at a broader scale, whether you can use some of those earlier indicators of soil health to give you an idea of what yield will look like at the end of the year. So next slide, please. Thank you. So work package 1, which is cover crops and water quality. So essentially we have this field on the right hand side here. So slope field, which has 4 different strips in it at one end of the field. So there's a bare stubble strip, which is to act as a sort of control for comparison. We then have a cover crop mix, which is radish, vetch, and phacelia. Another which is oats and mustard, and another which is buckwheat, linseed, radish, and phacelia. And essentially, we're looking at how those different mixes interact with the soil, how they interact with the nutrients that's applied, and how those then affect the following crop that comes afterwards. And these 3 cover crops, or these 3 cover crop mixes and the bare stubble, are then to be compared against an additional field which contains winter wheat, which is workshopped field, and that's to look at how actually whether or not winter wheat, by being in the soil over winter, provides some of those same properties of the cover crop in so much as they cover the soil over that winter period. And a core part of this is that we're looking also at the water quality. So FWAG and South East Water are both doing work to monitor soil quality. So they've got porous pots in each of these plots and also in the winter wheat and workshop. And they're monitoring essentially the concentration of various things like nitrates and that sort of thing within the soil water to look at how those are affected by whether or not you have a cover crop over winter. So a core part of this is looking at the soil health and how that's affected by these different mixes. So as the others have mentioned, VEST scores and that sort of thing. So we're going to be producing the soil health scorecards, which Nathan referred to in his talk. So it's a combination of looking at the visual soil structure and worm counts, but also looking at information that comes back to us from soil analysis that we send off to labs. And it's about bringing all of that together and looking at areas that are affected by these different mixes and how these different species within the mixes interact. So we're also therefore going to be looking at things like above ground biomass and looking at actually whether or not different mixes produce a different amount of above ground and below ground biomass, because that'll have implications for in terms of how they cope with different features. I'll cover one of those in a second, and it will provide quite a good example. And then it's about looking at a multi-year data set. So we're bringing together a multi-year data set of water quality and yield and incorporating that into this yield quality from this coming year. Next slide, please. So this is some of the early data that we've got. It all obviously comes with the caveats that this is early data and this is all the first time point of this data. So in order for to build a bit of sort of robustness, these scores will be repeated over time, and it'll give us an idea of how it changes with time as well throughout the year. So this early establishment data, where we've been looking at the percentage ground cover as well as plant counts in each of these strips within the field. We've been looking at both, partly because in some of the mixes where you've got more broadleaf things, so for example in the mixes with radish in, those have got those big broadleafs, so they're going to be providing a lot of ground cover, but they aren't necessarily actually going to have that many plants per unit area. So it's about looking at both of these things and potentially the implications that they may have for data that we collect further on in the year. So this is really that early data that we then, once we've got other soil health data, can look back at and see whether we can link these things together. So for example, here we can see that where you've got radish within the mix, it provides quite a good amount of above ground cover, but you don't necessarily have that high plant count. So that could mean that, for example, hypothetically speaking, if you have more plants in a unit area, you might have a better root, you might have a bigger sort of bulk of roots underground, which are manipulating that soil, holding it together and sort of reworking the structure. Whereas if you have much more ground cover, you're going to be less at risk of things like capping and that sort of thing from direct rainfall. So it's about looking at those sort of early features that we can link back. So next slide, please. So these are some early soil blocks that I extracted from each of the areas, and they give quite a nice insight into 2 features actually. So the first one being the role that the roots play in holding together that soil surface. So these are all sort of extracted and then placed vertically. So you can see that the plants are along the top there. And essentially what you can see is that where you have those cover crops in place that have been drilled back in sort of mid-September, so they've been in this ground a while, you can see they're holding that soil surface together and they're holding kind of nice, loose, friable aggregates together into one sort of cohesive structure. So you're not going to get too much soil moving away from where it should be, and it's also going to hold those pores in place and that sort of thing. Versus the stubble and the winter wheat, which didn't have such well developed root systems in place, and therefore the soil was much easier to sort of pull apart and didn't have that same sort of cohesive structure from the roots. It also quite nicely illustrates the importance of choosing sampling sites well. So in terms of the VEST assessments that will feed into the soil health scorecards, which is to follow soon, I'm going to be doing several replicates for each of these strips. And the importance of doing these replicates is highlighted quite nicely by the buckwheat, linseed, radish, phacelia image there, in that this, the strip of that is nearest to the headland. So it's possible that actually there's a bit more traffic along that area, which might be why you see this larger sort of ped of soil underneath at the bottom of that image, because there is likely to be more traffic. So it's about choosing those areas properly and making sure you've got sufficient replicates that actually you're looking at the effect of the cover crop and not other features of the field. Next slide, please. So I'll just quickly outline some of the core tasks that are going to be going on over the next few months, so that you're aware of sort of what's going to be happening on site. So one of the main things that we're doing, so that's going to be finishing this week, is looking at spatial cluster analysis. So this is developed by a colleague of mine at NIAB, David Clark, who essentially it's a method of correlating different spatial data for field sites, and it enables you to pick zones, sort of clusters of data where you're more likely to get comparable data, essentially. So you're not choosing a corner of the field that's particularly damp at periods of the year and another corner that's particularly dry, and trying to compare data between those. And that again feeds into that choosing the right sampling sites and that sort of thing. So I'm going to be continuing to assess the plant count percentage ground cover. So the data I showed you was for the 3 to 4 weeks post drilling of the winter wheat that's present in workshop, and that's going to also be studied at 5 to 6 and 7 to 8 weeks as well, to give that progression over time. They're going to be generating soil health scorecards, which Nathan referred to, and that's a case of undertaking those VEST assessments and undertaking laboratory analysis of soil cores and bringing that data together, and then also looking at cover crop biomass, so above ground biomass, below ground biomass, and doing that as a per species breakdown, and looking at whether or not different species thrive under different conditions, and how those bring biomass into the system. Next slide, please. So this is the second work package that involves cover crops. So this is looking at the effect of management on soil health and importantly on crop nutritional value. So it's essentially monitoring the impact of management systems on the development, health, yield and quality of the crop. So we've got 4 fields that are involved in this work package. So 3 of which have been under David Miller's management for about a decade. So that's 70 acres, which is in rye, Old Park and rye furlong, which both have cover crops and will go into spring barley. So those have been managed using sort of regenerative principles. They haven't had the livestock element or pasture element of regenerative agriculture, but they have had sort of minimum tillage and cover crops in place and that sort of thing. And then we also are comparing those against Typhreese field, which has been previously conventionally managed up until this year, and that's got a cover crop going into it for the first time. And it's about trying to monitor that transition, so following it through from being conventionally managed and seeing how it progresses into a sort of regen principles management system. So it's looking at how soil health changes over time, and how soil health varies between those fields that have been between Typhreese and the other fields and those different management strategies. And then it's looking at actually whether or not you get a change in macronutrient and in nutrient density within the grain that you take off at the end of the year from those various fields. Next slide, please. So this is the spatial clustering that I mentioned. So it's important within field trials, such as the one in work package 1, where we're looking at slope, the different strips within slope field, but it becomes even more important when we're comparing across fields, is making sure that we're getting sites that actually you can compare against one another. So for example, this is the spatial clustering data for rye, furlong and Old Park fields. So you've got the yield maps at the top there, and what you can see in the centre, in the maps in the centre, that's the spatial clustering map zones effectively. is that you've got this pink area of cluster 1 on the left-hand side in rye furlong, and this green area of cluster 2 in Old Park on the right-hand side. And those are the two areas which we're looking at, and we're thinking, okay, those are probably the ones we're going to be sampling from, and those will be the ones that we compare. They're consistently the most productive regions of each field. They're fairly distanced in from margins. They're not running along the outside of the field, and also they produce fairly similar yields in the year for which we have data for both in 2018. So it's essentially about how we choose sampling sites across whole fields for comparisons. Next slide, please. So again, it's those same early data of plant counts and ground cover, which come with the same caveats of being early data, but it's about looking at actually how that cover develops over time. So in 70 acres, as you'd expect with a rye crop, the actual sort of plant count's relatively high, but the ground cover is quite small at the time, as you'd expect with a cereal. But one of the interesting things to note from this, again with the caveat of being early data, is that actually the cover crop that was placed into Typhreese has not established nearly as well as those that are in Old Park and rye furlong. And there's quite a nice demonstration of why this might be in the next slide. So it's about looking at those differences early on as well. So next slide, please. So this is some pitfall trap data from fairly early on as well. So this is just looking at essentially what sort of insect populations you have within the field. This is also going to be repeated over time. This is just the first sort of snapshot of what's taking place in those fields. Again, on its own, this data doesn't necessarily, you can't infer too much from this data, but it's a nice early time point, which actually you can then look at additional data later on in the year and try and link back in and see where those trends may have developed. So one of the early things that you can see is that there's more caribou's have been found in Old Park and Typhreese, but again, it's about sort of linking that into later data really. So next slide, please. These are more early soil blocks that I extracted from each of the fields, and this one is again notable for two things. One, that if you remember, I mentioned that the cover crop in Typhreese didn't establish nearly as well. Well, when you look at the soil here, you can see that actually for Old Park and rye furlong, which both also have cover crops, but have been sort of min-tilled and that sort of thing and been in this management system for quite a long time, the soil in those is much more friable, much looser, smaller aggregates, which are more rounded and much more porosity and generally better structured. Whereas when you look at Typhreese, you've got those distinct layers and there's much larger aggregates with much less porosity. You can see far fewer roots coming through and much less organic material within the soil there. The other thing that this highlights as well is the importance of combining your VES assessment with also doing your soil texture analysis and things at the same time, and in the same locations. In actually what we're looking at is, so we're sending off to soil cores this week for a soil texture analysis, and actually what will be interesting to see is whether or not Typhreese, the difference in soil structure there as a result of the management, or actually it's possible that there's also some difference in soil structure, in soil texture, sorry. So it may be that also, in addition to the management, it also may have a slightly higher clay content, which would obviously also influence some of those features. So it's about sort of looking at all of those things in a whole picture. It's also noteworthy that it has a lower stone content from these images as well, and those flints are going to help to restructure the other fields as well. So next slide, please. So in terms of, again, outlining those core tasks, so it's like completing that spatial clustering analysis to make sure we've got comparable sites, looking again at plant counts, percentage ground cover at those next time points, developing those soil health scorecards to bring together physical and chemical information, and looking at cover crop biomass again and seeing how that influences those other features. Next slide, please. So I thought I'd also very quickly, this isn't as cover crop related, but I thought I'd use this opportunity because it's a new project to just outline the other two work packages very briefly. So the third work package is about establishment and early crop growth. So it's looking at assessing the impacts of two soil amendments, so EcoWorm and LCBF Boost. EcoWorm is essentially a soil inoculant, so the idea is that it contains a number of sort of soil microbial populations that you can inoculate soil with, and LCBF Boost is a molasses-based sort of starter fert. And the idea is that we can monitor the impact of those two soil amendments and compare soil health in these, what is essentially a tramline trial within this field of fish ponds. And the main thing that we're looking at is early crop vigor, whether or not these products actually boost microbial activity, nutrient cycling and that sort of thing, making more available to the plant, that being the sort of the logic of what we're studying, and seeing whether or not actually early plant growth and actually early root development, whether that's affected by applying these products. So we're looking at both the soil chemical and physical information. We're also looking at soil microbial information, so sending off samples to a lab, which gives us a breakdown of microbial, fungal activity, and also bacterial community activity as well. Next slide, please. So the final work package within this project is essentially looking at whole farm scale monitoring. So there's four fields involved in this, all of which are in winter wheat, and it's about capturing those early data points of soil health early on in the year in autumn, and looking at how that feeds through into the yield that you get at the other end of the year. So it's looking at whether or not you can use some of these things as indicators for actually what follows in yield. And that's sort of the summary really of the four projects. So next slide, please. Yeah, so that's the four projects, and that's the sort of roundup of the work to be undertaken.
Brilliant. Thank you very much, Callum. And I'm going to ask all the speakers to turn on their cameras and join us on the panel discussion element. Brilliant. They're lovely faces. They'll pop out. Brilliant. If you allow me to begin with, David, do you mind if I come to you, kind of to a bit of a kind of summary from you? There's a lot of information, a lot of data, and a lot of messages coming out there. Is anything there kind of struck a chord with you, and how would you use this information?
I think at the moment what we're seeing is what we had hoped to see. We've been doing trials ourselves for a number of years, so yeah, I think the information Callum's got so far is very much what we would hope to find. So it's going to be very interesting to put a bit more science behind that, a bit more sort of really relevant results, reliable results as we go further on. But very pleased so far with what's been found.
You've obviously been working with cover crops for quite a few years now in your career. And where do you see that? Where do you see the next kind of steps of your journey with it? How do you think you'll be evolving it anymore, or is it reinforcing what you're already doing now that you're looking to do?
I think it's probably it was a starting point for us. With the regenerative journey we started on, as you say, 10, 11 years ago. I think it's now adding the other bits to it to get the most out of it. You know, we've certainly found that, you know, from what the other speakers have said, sort of reinforces that this really is a very accumulative process. The more you can put cover crops in there, you know, every second, third, fourth year, whenever, but to keep doing that. And you know, we've certainly found that not disturbing the soil in between there is having a very big effect, especially on things like the worm populations.
Brilliant. One question's come in specifically for you, and that was how important do you feel that the drilling data is for the establishment to get the biomass where you need it to be? How crucial do you think that is in the process?
It is crucial, but it's not a case of it's too late to put a cover crop in. We've certainly found that we find a lot of difference in the above ground biomass between drill and dates, and this year is a classic example. You know, we've got nowhere near as much biomass on top of the ground, but actually underground the roots are doing almost as much as they would have done with a better or higher biomass crop.
Brilliant, thank you. And Anne, you've been involved in the maxi cover crop project that we have. Does that correlate? Does that kind of that early drilling side, does it correlate with all the information, with what the outcomes of your maxi cover crop project?
Yeah, we certainly found that early drilling was important in terms of getting that cover and actually mopping up nutrients and the cover actually doing what it should do. So we sort of found really, so as you start slipping into September and certainly late September, I mean, it depends where you are in the country and it depends on the season, of course, and your soil type. But we found that drilling date was important, as was destruction date, certainly on heavy textured soils, getting the covers off and allowing sufficient time and a gap between the cover and putting your next crop in is almost as equally as important for the success of the next crop.
Kind of touching on that, one person's asked if you were to mow and then cultivate the cover crop before a spring crop, does that fit with this less is more approach? And I'm not sure what angle they're coming from there. What do you think to that?
So sorry, mowing and then getting, yeah, I mean, yeah, if it works, then I think it's worth a go.
Yeah, brilliant. Question that came in when Nathan, when you were on, do you think the cover crops are using available nutrients, leaving the soil less fertile for the following cash crop? Did you have any thoughts on that?
Yeah, very good question. Potentially they could be. You know, we've seen how they can mop the nutrients up, and that's really the challenge I think that's currently facing us. Is we've got good data on how those cover crops can capture that nitrogen and stop that leaching sort of in the winter period of the cover crop. Where we're less certain really is when that nitrogen or other nutrients become available in the following crops. And that's when it gets complicated, because there are many drivers to how those nutrients are released. You know, temperature, microbial activity in the soil, again talking about the wider, you know, impact of farming systems, cultivation intensity, all those sort of things that drive microbial activity that will drive how those nutrients are broken down and then released into the crop. So it's one of those things where I suspect that is certainly an important role, but actually putting numbers on it is quite difficult.
Brilliant, thank you, Nathan. This came in very early, so I assume it was when you were talking, Anne, so I'm going to link it to you if that's okay. Were all the crops preceded by a cultivation pass? Were any zero-till establishments considered, and what do you think the effect would have been if they were used?
So cultivations were used for the establishment of those catch crops, and then the establishment of the following crop. I think, yeah, I mean, cover cropping is often linked with reducing cultivation and enables reducing cultivation. The idea being that you get the roots to do the work as a cultivator would do. So I think potentially, I mean, we didn't have a cultivation treatment. It would have been nice to have then had sort of split the plots, as it were, and had cultivated versus not cultivated system. So I would be guessing, and I would also guess that it would be soil type dependent. Sometimes you do need to get in with a bit of cultivation just to help if there is particularly high levels of compaction. But equally, you know, the cultivator could destroy some of the good that the roots have done. So yeah, we haven't tested that per se.
Brilliant, thank you, Anne. Another very open question, apologies, but David, somebody's asked how much do you think it is acceptable to pay for a cover crop mix? So basically, can I ask your opinion on kind of budgeting and kind of what would you expect to pay, and would you go for the kind of cheap and simple, or is it kind of you get more for what you pay for?
I think you get what you pay for. We don't buy any mixers at all. We've got to the stage now where we actually chuck a few hectares of certain species in the ground to harvest, which helps reduce the cost a lot. We sort of have a couple of big no-nos with our cover crops, in that we don't put any brassicas in there at all. We find, I mean, I know Callum's got some with the trial plots, but as a general rule over the farm, we don't have them. We found an enormous problem with slugs in a wet year with brassicas, and also we've got oilseed rape in rotation. But also we don't put any cereals in, and we try and take out any volunteer cereals we get in there. So we're trying to sort of major on legumes, clovers, beans, lupins, things like that, as well as phacelia, buckwheat. So we we sort of got our cost down to around about £30 a hectare for the seed, which I think is where we want to be.
So another question I'm going to ask the panel who feels confident answering it. Many green manure cover crops encourage pratylenchus, free-living nematodes. Apologies for the pronunciation. What is the danger of this unintended consequence? Should we be more aware of this? Does anyone willing to help us out on that one? So the cameras go off.
I can make a comment at least. I think there are a lot of these, if you like, green bridges, and the challenges of the pests are as much of the systems and including cover crops as your main crops. And as David's just alluded to, the brassicas and if you're growing brassicas in a rotation, we've certainly got some evidence there of there's certain soil-borne pathogens in brassicas that can obviously be carried over with the cover crop brassicas, and so I suspect other the nematodes could well be a similar thing where certain species help sort of carry over those. But more work really is needed, in my opinion, on that, because we really don't have a strong understanding of implications. And same with legumes as well. We've still got implications of having clovers and vetches with peas and beans. If you've got those in your rotation, we don't really know those impacts really. I'm sorry, not very helpful, but it's an area for certainly further research.
Thank you for giving it a go. I've got another one for you, Nathan. Nathan, you showed that 85% to 85% of all earthworms are juvenile that cannot be readily identified to species level. Even if farmers could identify all the species to functional groups, how do you practically chase down an anisic earthworms to make deep vertical tunnels up to 2 meters long and inhabit their tunnel throughout their lives? Does that make sense? Sorry, I didn't read that very well.
I thought, well, earthworms again are all very much driven by the soil type, the conditions, the weather, the climate. So it's quite difficult to have particular management changes to affect those populations. But yeah, certainly the anisic, the deep burrowing species are the ones that we want to encourage. But yeah, sort of monitoring those it can be difficult, and even the differences in seasons. I suspect when I go back again next spring, we may well see very different populations just from the seasonal effects.
Brilliant, thank you, Nathan. Callum, why are you choosing not to use historical yield potential index using satellite maps of ground cover and biomass to guide your sampling?
So part of this reason is because it gives us we get a very good spatial resolution from using actual yield maps and that sort of thing. I should also mention that we're not using those in isolation as well. So rather than just relying upon yield maps to collate these clustered zones, we are also using information from David himself in terms of any knowledge that he has about those specific fields, areas that are particularly prone to waterlogging, that sort of thing. And we're also collating that also with data and information from David's agronomists as well. So we're not just looking at that in isolation, but a large part of the reason why is because of that resolution, and because we can then choose those data points from years following winter wheat, for example, so we get comparable yields across.
And when you refer to regenerative, to what degree is this? Zero till, min till, or just scratching kind of on the surface? What's your thoughts on that?
So it can mean any. I mean, regenerative agriculture generally is a fairly sort of loose concept and can mean different things to different people. In the case of this, I believe, David, you sort of transitioned from reducing your tillage through to doing much reduced tillage to no tillage, I believe, in many of your field sites. Is that correct? Yeah. And it's been a sort of transition over time. So in this instance, it means that sort of transition through reducing tillage over time. But it can mean regenerative farming can mean taking the power harrow out of the shed slightly less often, through to doing absolutely no tillage whatsoever and never disrupting the soil. And again, also in strict terms, regenerative principles would also include involving livestock and permanent pasture within the system, which isn't present here. But it's those same principles of reducing tillage where possible, putting in cover crops to cover the ground surface, and maintaining a root system in place as well.
Was more of a statement here, and I'm going to ask David whether he agrees with it or not. Can we agree that establishing a cover crop after harvest ahead of a winter crop is really insignificant and possibly a waste of time compared to maintaining a green cover over the winter ahead of a spring crop? Would you agree with that, David?
Insignificant. I think it very much depends on the season. We've put some catch crops in after spring barley before we put in winter beans, this sort of thing. So the gap is quite important. But if you've got a very growy time with, heaven forbid, another wettish harvest, and you're managing to get stuff into good seed beds early on, then it can be a big benefit. But it's not as big a benefit as obviously putting something in that's going to be in there for 6 months.
Thank you. Stay there, David. I've got another one directly for you. Question for David. Would you consider using rotational elements to give an early August entry for cover crop, for example, winter barley or rye for a biodigester, given that an early sowing clearly gives significant better results?
I don't think that's something that we would do as a one thing that we were trying to achieve. I think if it happens that we have winter barley and we're putting a later crop in, then we would do it. We wouldn't grow rye for a digester. There's real issues with nutrients being taken away and that sort of thing. So yeah, it does come down to species as well. What you put in, put stuff in that's going to grow away very quickly, and stuff like buckwheat, which is a fantastic stuff to get up and go and can capture an awful lot of phosphate. So it really depends on your list of what you're trying to achieve.
Thank you, David. One for you, Nathan. In terms of nutrient release, is it fair to say that you might get a lag period of nutrient release at the start of your cover crop journey before the first year starts releasing further down the line? So really you're always planting cover crops for 3 years down the line, for example. Do you agree with that?
Yep, absolutely would agree with that. I think there is a lag time. I think that's also part of the journey that we're probably going on if we are using cover crops, that we need to look at those in the longer term, as David mentioned, and the changes in the sort of structure of the soil, the microbial activity of the soil will all help shift that dynamic to the nutrient release. But yeah, the release period is difficult to quantify, and from my personal experience, I don't think you would necessarily see sort of a large release in a very short time frame. I think it's more like a dripping tap. You just see that constant little releasing of the nutrients over time, and it's whether we've got the crops in the ground to capture that in the right conditions, really. Yeah, it's a difficult one, but yeah, I think that's how I see it.
Anne, is Anne still there? She's disappeared off my screen.
I am still here, but I seem to have lost everybody else. So I can hear you all, but I can't see you.
We can hear you. Is there any data for nutrient capture where cover crops were grazed by livestock?
So is there any, sorry, say that again.
Is there any data for nutrient capture where cover crops are grazed by livestock?
Actually, not a lot. We have been involved in an Innovative Farmers Field Lab that looking at grazing of cover crops, so we should have some of that data down imminently. But as yet, I don't know whether we do have that information. I don't know whether anybody else is aware of that.
I'm not aware of a huge amount. NIAB also involved with the SARIC project, looking at herbal lays, so sort of more complicated cover crops, but herbal lays and grazing with livestock. But yeah, there's probably a lack of information on that nutrient availability from those systems.
I'll come to you, Nathan, for this one. After 15 years of controlled traffic and progressively less tillage and increased worms, we're starting to get significant grief from slugs, which cover crops only serve to feed. Is there any intention in the trials to monitor the effect of cover crops on this devastating pest, as well as the nicer things that we are measuring? So I'll go to Nathan and then Callum for that one.
Yeah, I think there's, I mean, absolutely, there are opportunities. I mean, it's the same thing, really. It's all about choosing the species, choosing how you grow them, choosing how you destroy them as well. If you feel there are, challenges with cover crops, then, having a sufficient time to destroy them and actually let the material break down, and not having too much sort of residue, if you like, going into a spring crop, because that's obviously where those, for example, slugs will be an extra challenge. I have to admit, some of the fields I've been doing long-term work with cover crops on are on lighter soils, and then, well, in a nice way, don't get the same slug pressures as heavy land farms. But yeah, absolutely, it's something we should be looking at.
Brilliant.
So in terms of speaking to the Strategic Soil Farm South, so monitoring insect populations, slug populations, and also monitoring pests and diseases more broadly is quite a core part of the work. So in all of the work packages, and in all of the fields that are being studied, we're doing ongoing sort of insect monitoring, pitfall traps. We're also going to be doing sticky traps for orange blossomage and the like, and also monitoring disease and whether or not that develops in any of the field sites. So in terms of monitoring actually how those things are affected by the preceding cover crop is a core part of the work that we're going to be sort of undertaking ongoing monitoring on over time to see whether or not different mixes affect populations in different ways and that sort of thing.
David, I think this is kind of touching on, Brian did touch on kind of the public money for public goods in kind of his video, and that kind of angle of looking at this. And the question for you has come in kind of, David, do you feel that the growing of cover crops should be incentivized? Are we in danger of becoming too obsessed with the nutrient retention element of cover crops, given the many other benefits of soil, water and biodiversity that they provide? We need to develop these other public goods if we are to facilitate future funding streams. So I'll go back to the earlier question of that. Do you feel that they should be incentivized to be used?
Well, they are incentivized for us because we're in the stewardship scheme. So a third of our farm is into cover crops every year. So we're getting paid for that. I think there are certainly a lot of water companies down here that are trying to incentivize growing cover crops to stop algal blooms in some of the estuaries and that sort of thing. Yeah, I think we would do it anyway. I think we can now see enough benefits. Nutrient capture is one thing, soil structure is another. Just the whole environmental thing, from anything from microscopic stuff in the soil right through invertebrates, right the way through to the bigger mammals and stuff. I think we can see enough benefits that has convinced us to carry on with cover crops. I would question, if you're spending £60 a hectare on a mix, whether that's worth it. But certainly, if you can make that mix cheaper in various means, then yeah, 100%, definitely worth doing.
Brilliant, thank you, David. We're coming nearing the end of the webinar now, so I'm just going to ask a couple more questions. One thing that did point out, Kelly from Anglian Waters mentioned on there that Anglian Water are currently looking at a trial looking at the impact of grazing sheep on cover crops on nitrogen losses. So that kind of ties in with what we were saying with Anne. So there's watch this space. They're working with ADAS, and there is more information to come on that. It's an evolving journey. I'm gonna go last couple. Nathan, from your side, it's difficult to say when the nitrogen from legume will become available to the cash crop. Do you have any thoughts?
Yeah, I mean, we've got this parts of Ryan's sort of farming is with the cover crops and the barley, spring barley going into the 2 years of herbage grass is a way of sort of hopefully capturing the nitrogen, or not just nitrogen, the nutrients across a sort of wider window than you would with just a cash crop. But the availability of the nutrients and when they are become available is something that we will sort of try and continue to monitor and work. But as I say, it's very difficult to monitor when those things are or when the nutrients are being released. It's not, and well, we're hoping this year also to use. We've got some partner who's been developing a nitrate probe that will actually look at the soil nitrates in real time. So we're hoping to install those in the field early December. So again, we can try and tie in with the sort of nutrient movement through the soil profile and the drainage water samples as well to see, are we seeing movement of nitrate through the profile at that very increased time definite level, if you like, and then also, what we're seeing in the drains. But like in all science, I'm sort of hedging my bets as what we saw last year is to try and see if we can capture that again, and then knowing my luck, it'll probably be something very different this year. We'll probably get a very dry winter and not so much leaching, I don't know, but yeah, we'll certainly look at that.
The final question, and it's not even a cover crop question, but it's a myth busting one. Is it true that worms eat slug eggs?
Oh,
I
don't know the answer to that.
Anybody has a guess on the panel? No. So, sorry, Andrew. I'll have a look into that one. I'll see if I can get an answer on the back of it. It's Andrew. Thank you for that question. Brilliant. That takes us to the end of the allotted session today. 1 minute over, which is good going by my usual chairing. Just a big thank you to all of the people, all the researchers, Callum, Nathan and Anne, and also to David for joining us today and providing their input and providing us with the content, really. We wouldn't be here without any of them, and to do that. So we're really grateful for everything that you've provided us. Just a small reminder to signpost you towards, there is a huge mammoth amount of resources in this area under the Great Soils banner at AHDB. Make sure you use it. Your levy funds it, and it's driven and created for you. So be mindful to have that. So all that leaves me to do is thank everybody here. Thank you for attending, and thank you for all the questions, comments and challenges as we've been through. It's made our job a lot easier. And we hope to see you at the next 2 webinars of this week or at one of our events. So thank you very much, everybody, and have a good day.